All right, number 8 on section 1.8 of calc. So this one, I kind of messed it up because I was thinking this was the original function, but not the derivative. I didn't look carefully and see that. So this gives me the slope of some graph. Now, just so we have an understanding of that, I'm going to graph this. And we're probably going to need it anyway. So it's parenthesis x minus 1, close parenthesis, e to the negative x squared. Okay? And I'm going to go zoom 4. And can you see? Let's see, let's put it there. You can see that. I could zoom in a little bit more, but let's just, it basically is below the axis, goes down negative, comes up, and goes above the axis and there. Let's zoom in. Zoom in that spot there. So it gets closer and closer, and it gets down here, and then it goes this way. So what does that mean about f? And this is going to be a rough sketch. It's got almost no slope, going to a very negative slope. The slope goes to not very negative. This is minus 1. So it has almost no slope, and I'm not sure where the graph is, but it's a little bit negative in its slope because the values here are very slightly negative, going to a slope of minus 1 here, and then it gets a little bit steeper, and then it starts getting less steep because this is coming back up. Get it over here where you can see it. This is starting to come back up, and then it's getting less and less negative, less and less and less negative, till it gets to a slope of 0 at 1, and then it goes a little bit positive, and then it goes back to less and less. So this is a graph like this. It has a slightly negative slope getting to a more than negative 1, more in absolute value, less than negative 1, steeper than negative 1, then less steep than negative 1. All goes back to a slope of 0, and then it goes to a positive slope, but only slightly positive, and then it heads towards a slope of 0. Okay. At what value of x is the first derivative equal to 0? This is the graph of the first derivative, and it is 0 only at 1. At what value of x? 1. Justify your answer algebraically. Put 1 in here, we get 1 minus 1 times e to the minus 1, negative of 1 squared, which 1 minus 1 is 0. So this is just 0. The slope is 0 at 1. Reason graphically for what intervals of x is the second derivative greater than 0? Is the slope of the slope. This is curvature of this one, but it's the slope of that one. And so when is the slope of this positive? Well, the slope is not positive until we reach 1, and then, the slope is positive of this. The slope of the first derivative, the second derivative, is the slope of f prime. And this says positive. So when is the slope of this positive? Well, it changes somewhere in here, and it's positive. The slope of this is positive all the way to some place there. And those places, we can go second, calculate the min. That's between negative 1 and 0. And I'm going to guess negative 0.5, and it tells me at negative 0.336, negative 0.336 to, so I'll do interval notation, to the max here. So I'm going to go second calculate the max between 1 and 1.4. 1, enter, 1.4, enter, and my guess is 1.3, and it says no. Oh, it says 1.36, so I was right. Did I guess between 1 and 1.3? 1, let's see. Second, calculate, make sure I got included that. Maximum between 1 and 1.4, and my guess is 1.3, and it says 1.366. 0.3366, yes. That's when the slope of this is positive, and so that means that's when the second derivative is positive, because the slope of the first derivative is positive, the second derivative is positive, and that means the curvature of the original graph is concaved up. And so from negative 0.336 to 1.366, this graph is curved up, concaved up. This place is 1, and this is where it's curved up. Assuming that f of 2 is negative 3, f of 2, so I need to move this whole graph down, so at f of 2, wherever this is at minus 3, so I need to move it all the way down there. So it's moved down, and we're supposed to estimate the value of f at 1.88, which is near 2. So I'm going to need to create a line, at a tangent line at 2. So I'm going to need the slope at 2. Oh, this thing, it tells me the slope. So this equation will tell me the slope. So I'm going to go second table and put in 2, and it says the slope is 0.018. 0.018. The original graphs at 2 has a positive slope of 0.018 times x minus, we're doing this at 2, so subtract 2, plus f of 2, which we have no way of knowing until they told us this. It's a minus 3. And so now if we're going to go at 1.188, which means we're putting negative 0.12. 1.88 minus 2 is negative 1.12. So we're moving a little bit back this way. And that, if we're at negative 3 and we add more negative, it's going to be down a little bit. So we're here and we're down a little bit from it, moving back. Let's see what that works out to be. Second quit. We got 0.18 parenthesis 1.88 minus 2 close parenthesis minus 3. And we get it's negative 3.002. So the graph was still going up. It had a positive slope there at 2. And we're moving back a little bit, and we were already down at minus 3, and it had a positive slope, so it's coming down and being a little bit more negative. A little bit more negative. And I don't know if I showed you all that while I was doing it, but that's what we're doing. Missed it. Dang it, I keep forgetting to do that. All right.